Okay, so we're talking now about analytical methods and drug metabolism. And so we left it off last time where we were talking about radioisotopes and looking up for where that radioisotope that was in the initial drug, where it shows up over time. So that would be what organs in the body it shows up over time and this kind of thing. And so that is definitely the gold standard. But we always try to not use radio labels whenever possible. That's always kind of the rule in science. It's always the acronym is ALARA, which is as low as reasonably achievable. You never want to be exposed to radioligands because they are carcinogenic. And so with that, we've developed some better methods to, or not better, but I would say safer methods to detect drugs as they pass through the body. Now, they aren't, of course, the gold standard, right? But they're still good. And so they're used a lot more in modern metabolic analysis. And so what we do is this kind of multi-phase separation process where we're going to use a chromatographic setup. We're either going to do some ion exchange or we're going to look directly at something like urine, and we're going to then do likely mass spec or NMR with mass spec. But the thing is that for a lot of it, it would be really nice to use NMR after our chromatography steps, but we're typically dealing with amounts of drug that are way less than a nanogram, and so it can be kind of hard to separate signal from noise, getting that we're going to still probably get a mixture of compounds in all of our chromatography peaks. Okay, and so what I'm going to do in this next slide is I'm going to do a little breakout slide where I discuss how that workflow goes.